Yeti crab is great. The Yeti crab is a crab that's found at hydrothermal vents. And this crab is basically farming bacteria all over its arms. That it has these little sort of spikes or filaments that it then uses as surface area so that the bacteria have more space to grow on. And so they essentially have their arms covered in bacteria, and they have this great behavior where they position themselves so that they can wave their arms in and out of the hydrothermal fluid, because the bacteria they're farming need the chemicals that are coming out of these deep sea hot springs. And so in order to facilitate this, they want their bacteria to have access to all these chemicals, and so they all are waving their arms back and forth in the chemical fluid, trying to get their bacteria more and more access to the chemicals. And so then they're growing them on their arms, and then they basically scrape their arms off, and then consume these bacteria. So this is more, I guess, what it's definitely a symbiosis, but I think it can be called more of a farming in the traditional way, where they're growing their own food by manipulating their food source and like facilitating that. And this is different than some of the other symbioses, like the tube worms that I mentioned, where those animals are actually, this symbiosis has evolved even farther, where the animals actually have these bacteria inside their tissues. And so they don't actually need a mouth anymore, because their food is living inside their bodies and growing inside their bodies.
Fascinating that a Yeti crab would know, I need to wave my arms in front of this hot vent, right? Yeah. So, there's hundreds of them in these dense groups, and they all are waving their arms back and forth. So it's pretty wild. It's like a Yeti crab rave.
Yeah, exactly. A party. Yeah.
That's great.
Yeah, dancing in the dark is what I've heard people say.
Oh, that's good. Well, I know you study snails in your lab. Mm-hmm. Can you tell us a bit about the snails and what makes them unique, the ones that you study?
Yeah. So this is Alvinaconcha. It's a genus of snail. There's actually 6 species of Alvinaconcha in this genus, and they're found at vents all over the Western Pacific and Indian Ocean. And so this Alvinaconcha you're seeing here is a very large specimen, and they range in size, and this is one of the larger ones. And so you can see it's, maybe baseball, softball size, if that's my hand there for scale. And Alvinaconcha is the dominant, or one of the dominant animals at vents in the Western Pacific and Indian Ocean. And you can see it has this really great spikes all over its shell. And they actually feel more like Velcro. They're not very hard spikes. But one of the species of Alvinaconcha is named Alvinaconcha strummeri, which is named after Joe Strummer of The Clash. And this is the punk rock snail, is what it's been coined. And so Alvinaconcha hosts bacteria in its gills. So it still has a mouth and a gut, but we don't think it uses these things very much. But it's getting its food entirely from the bacteria that it's farming inside of its body.
And named after the fellow from The Clash. Who says scientists don't have a sense of humor? Right?
Yeah, talking more about the animals and organisms that live at vents today. Interestingly, a lot of those animals actually come from shallow water environments. So they're not that different evolutionarily from organisms that we see on our coast. For example, there are some mussels that live at hydrothermal vents around the world. They're different species, but they're all very closely related. And they are very closely related to mussels that we commonly see on our own shores in coastal environments. So what we think is that these organisms have evolved to capitalize on these ecosystems in the deep sea. And so that's where they've come from, coastal ancestors.